show you guys how to do a slab with an area drain slope in it for situations where you have a design model that may not represent area drain slopes. And additionally, I wanted to show you how to create a parkade clearance to represent any height clearance or minimum height clearance that you'd have in a parkade. And then additionally, I want to show this same sort of approach when you have a slab that has multiple thicknesses within the same footprint. So you can see here from a couple examples I have where I've modeled slabs that actually have 3 different thicknesses. So one is 400, one is 150, and one is 250 thick, and how you can model those 3 different slab elevations that fall within the same area drain footprint. So what I'll do just to get started is show you what this looks like in Navisworks. So basically I've exported these out as NWCs and appended into Navisworks so that you can see how this example would look like in your coordination model, and then you can obviously push it to Revisto if you so choose to, or any other coordination platform that you're using. So couple things to make note of before you get started. And again, I just modeled these slabs so you can see what the finished product looks like. But the first couple things that you want to do is set up your 3D views. And the reason for this is because you want to also export your parkade slab parkade clearances as their own NWC. And then the slabs, if you so wish to choose, or if you choose to put them into your coordination model, both as separate NWCs so that you can control the visibility of them in your coordination model quite easily, and then additionally use the parkade clearance placeholder as an element to use in clash detection if you want to do that as well. So over here I have 2 3D views set up, one for parkade clearances and then one for slabs. So one thing that you want to do in order to control the visibility of these is set up a work set. So what I have is a work set set up for parkade clearances and then one for slabs. And then how you would set those visibilities up in each 3D view is just by clicking visibility graphic overrides, work sets, and then just simply adjust the visibility settings for whichever 3D view you're in. So for example, we're in slabs, so we're only going to show the slab work set. And then you'll see here that the work set for the slabs is obviously set to slabs, and then likewise for parkade clearances. And then I have an overall coordination 3D view just to kind of see everything all in one 3D view. So I'm going to go ahead and get started just with a standard single thickness slab, just to show you that very quickly. So I'll just use 150 mil thickness floor slab, and we will create that. So once that slab is created, and I'll go 3D view to show you that, so you see it here. The next thing you're going to want to do in plan view is add a point. And what that point's going to represent is the area drain itself. So I'm just going to put it here in the middle. Sometimes you might want to put different ones around the corner, but just for the purpose of this video, I kind of wanted to show you the basics. So once you have that area drain point added under add point, then you click modify sub elements and click on that point, and I'm gonna go pretty extreme here and say it's 400 over. So you always want to use negative numbers to obviously set up lower, and as soon as you press enter, you can see here that it's created that depression. So I'm just going to click edit boundary, finish edit mode, and that's done. So I'll go to the 3D view so you guys can see what that looks like, and you can see here that we have a slab now with an area drain depression. So it's easy as that. So the next step is, and you can do this in 3D view or 2D view, whichever you choose. So you want to select that slab element again and click copy and then paste. And when you're copying and pasting something, you gotta be really attentive to where you align it. Otherwise, your slab elements might not align not vertically, but horizontally in the X and Y orientation or X and Y layout. So in Revit, you just want to make sure you're at the edge of this line and that the digits on it say 0, 0, so that there's no offset whatsoever. And click enter, or just click on that, and you have the second floor slab pasted. Click finish, and it's going to tell you that these floors overlap, which is fine. So the next thing you want to do is click on the element and just adjust the height offset to whatever your parquet clearance is, or clearance in that location, whether it's a service corridor, maybe a mechanical room, whatever. And I'm going to just choose 2700. Apply, and there you go. Now the next thing you want to do is then change that floor family to a parquet clearance family. So I've already created one, so I'm going to just set it to that, and I'm going to actually open it up so you can see how I've adjusted the thickness if you guys don't know how to do that. So you just click on structure or edit under construction, and then the thickness can just be adjusted right here. So what I've done is I've set that to 1 millimeter. So that should be good. And you have a floor depression with a parquet slab clearance, or a parquet clearance or service clearance. And the nice thing is when you copy these elements and paste them, it basically follows the profile of the floor slab that you just modeled. So anywhere along this area or footprint, you have the same clearance no matter what. So the next one, which is a little bit more tricky, is for multiple slab thicknesses. So I'm going to go ahead and just get started and create, I'll create 3 different floors. So the first one will be 150 mil floor. So I'm going to start, do that, and then create my second one. And then obviously you guys can do this in 3D view or 2D view. I'm actually just going to switch back to 2D view because I am in 3D right now. And whoops, I need to go back to 3D view because I made a mistake and created these with the wrong work set. So that's one thing you want to be careful about with work sets. So I changed it to work set 1, and okay, I can't see it here. So I will just check to see what elevation it was set to. Okay, so the reason why is I had it set to the wrong level. So you always want to make sure that you do have it set to the same or the correct level, of course, in your project. So I'm going to set it back to level 1. Apply. You can see how they moved up, and I can see it in level 1. So just a little troubleshooting on the fly. So the second one I created, I'm going to change that to a 250 mil slab. So that is now 250, and then I'm going to create a third element, or a third floor element at 400 thick. So again, I'm going to quickly make sure that it's set to work set 1 first. And just switch it to, or just draw in my slab. And 400. So I'm going to go to 3D view, and you can see that these 3 slabs have different thicknesses. So I'm going to actually change the visibility here so it's a little bit easier to see. So you can see here that you have varying thicknesses of slabs, which you'll probably encounter in parquets quite a bit, or other structures as well. So I I thought it would be helpful for you guys to know how to create a depression where you have these multiple thicknesses. So the next step you have to do is create a sacrificial, I like to call it a sacrificial floor element, to represent this overall area. So we're going to assume that this footprint of the 3 slabs is the whole entire area drain depression footprint. So what I'm going to do is just create a 4th slab element to span all 3 of these, and actually I'm going to do it in 2D view. So I'm going to make it the same footprint as all 3 of these slabs. And I'm just going to go ahead and make it 150 mils, because the important part is the top surface of this slab element, and you'll see in a minute why that's important. All right, so I just want to make sure that it is at the correct elevation again, and it's not. So I'm just going to switch it back to level 1. And it's telling me that the floors overlap, which is fine. So I'm going to select that one single sacrificial floor element. And what I want to do is I want to isolate the view, the visibility on that one specifically. So I'm just trying to find the isolation view. So because I have it highlighted, I just go isolate element, and that's all I can see. So now I'm going to go back to, I'll just do this in 2D view. So I'll just repeat the same steps again. And so I'll start by selecting the element. Whoops. And temporary hide and isolate. So what I want to do is add wherever the area drain is going to be in this one. So I'm going to put it off a little and make it skewed a little bit. So this is where my area drain is going to be. I'm going to make it 400 mils below, or 400 mils lower. And there you go. So the next thing I want to do is obviously turn off the isolate view. So now everything is visible again, and I'm gonna, oops, don't want to reveal. Okay, so now everything is visible again, and my one single sacrificial floor element has that area drain depression. So I just want to finish those edits. And now what I want to do is turn everything, all 4 elements, into wireframe view. So now everything is in wireframe, and you'll see why I've done that in a minute here. So before I get started, I want to create I want to add points to each of the 3 floor elements that I was working on. So I'm going to start with the first one. I'm going to add a point, and for this step, the reason I'm doing it is we're creating nodes or points along each slab that can then intersect the lines of the sacrificial slabs. So it's a little bit difficult to see here, but when I go through the steps, it'll make a bit more sense. So one thing you want to be mindful of is you want to be in a top-down view in this case, so that your points that you're adding to line up with the contours of this floor slope for the sacrificial slab are in the correct location. So I'm going to go ahead and just add them in here. And that's the only one that I need to add for this one. And you're going to probably wonder, well, this corner right here might actually be higher, but we'll get to that one in a minute, a few steps later. So now that I've done that, I'm going to click Edit Boundary, done, and then I'm going to repeat that same step for the other 2 slabs. So add a point. Finish, and then lastly, the thickest slab. So I want to add one obviously where the floor drain is, and then one for the other 2 contour lines. All right. So what I'm going to do is start with the big slab first, and I'm going to just go back to 3D view. So you need to do this next step in 3D view, or sorry, at an angle so you can see the lines of the sacrificial slab. So I'm going to select, or still have selected the thicker slab, and I'm going to go to modify sub elements. So I'm going to click the area drain one first, and you'll see here that it gives me a number, or because I'm in 3D view, it'll let me just drag that elevation. So I'm going to actually go ahead and just type it in. I didn't mean to go 200 high. Negative 400. So now I am matching, or should be matching, the sacrificial floor element. And the next thing I want to do is take this node and drag it down to line up with the geometry of the sacrificial floor element. So that's this line right here. Sometimes it can be tricky to know which one it is, but with a bit of practice, you'll get that. So I'm going to drag it, and as soon as it highlights the contour line of the sacrificial floor element, then I know I'm aligned. And I'm going to do it for the other point. I just want to get my view orientated so I can know that I'm selecting or lining up with the correct contour line. So you'll see here that at this point it's negative 324, and if you take a pivot around, you'll see that this 400 slab is now matching the contours of the overall area drain footprint. So that's kind of the whole point here. So I'm going to click at it. And then now I'm going to do that for the 250 thick slab. So select that one, modify sub-elements, click on the one point, or I like to call it a node. So I want to try to orientate myself again so I can see that contour line of the sacrificial slab. And sometimes it's a little bit tricky to get the right one, but there we go. I got it. And then I'm going to leave the middle point where these two slabs intersect, and we'll get to that one in a second. So I'm going to finish editing that one, and then pick the 150 mil one. And there we go. Now, the reason why I wanted to leave this step to the last is because what you'll see here is, I'm just trying to figure out the best way to explain it. The 400 thick slab in wireframe has a line, and I'm going to just try to get out of this view. So you see right here where my mouse is, that is the profile of the 400 thick slab, and what you want to do is take the point of these two slabs and line it up with that. So I'm just going to go ahead and do that with the 150 thick slab. Oops. By clicking modify sub elements. And there you go. It's lined up. And then we'll just finish editing this one and then select the 250 thick slab, modify sub elements, click on that one, and bring it to that line. So there you go. It's as easy as that. So what I'm going to do now that I'm done making all these three separate floors depressed to this one area drain location here, I'm going to delete the sacrificial slab element, hence the name sacrificial. So you'll see that everything now lines up because you have wireframe to verify that. So the top surface of the slab all lines up with this, how it should be in a parkade or whatever area this is. But on the underside, all the different, well, I'm going to actually switch to a different view so you can see that better. All the different slab thicknesses now, for all the same profile, but you at least have those different thicknesses represented. So if you're working in any sort of space where you have this parkade clearance created below this slab, Now you can also represent different slab thicknesses for the floor above that would affect this annular space between a parquet clearance below here, theoretically, and the slab above. So again, I'm just going to delete that sacrificial floor element, and now I just have the 3. So same thing with the single floor slab. I'm just going to copy all 3, or select all 3 at once, copy, paste, make sure that it's lined up, and so there's no offset, and paste, finish, and it says my floors overlap, which is fine. So I'm going to select all 3 again, and just move those up to 2700. And again, as the next step, I want to just switch that to a parquet clearance. All right. So now that I'm in the coordination 3D view, I want to make sure that I've made my slab elements all the same work set, or the correct work set to show up in the slab 3D view. So I've selected all 3. I'm going to set them to slab work set, sorry. And now they are slabs. Or actually, sorry, I need to do that in this box under parameters. So I'm going to click apply, and I'm going to go to the slabs 3D view, and there they are right there. So I didn't do that for the parquet clearance on the first example, and it's showing up here. So I'm going to go back and complete this process for the parquet clearances now. So I'm going to select all 4 of these and set the work set to parquet clearance. Done. And you can see here that I have all the parquet clearances shown. So again, just to reiterate, the reason why I want to do this, whoops, I'm missing a slab there. Let me go fix that. All right. So the reason I have these 2 3D views is that when I do an NWC export, it's only of these 3D views. So I'm not going to do the NWC. Sorry, I am going to do the NWC, and I'm going to actually just save over the existing parquet clearance NWC that I've created already. So yes, I want to do that. I'm going to do the same thing for the slabs. And save over. So I'm going to go to Navisworks and just press refresh, and there you go. So there's the slabs. Now, there's a few ways you can preset the visibility through materials if you want in Navisworks. I honestly haven't quite gotten that figured out. So what I actually do, just as an easy workaround, is just simply select the visibility, set the visibility settings in my NWF. The reason I mention it's sometimes better to do this in Revit so that you can just skip this step. So whenever you do update your NWC, you don't have to remember to do the additional step of changing the visibility and putting a transparency on that parquet clearance, because that's the thing that you want to do, is make sure that it's a color that's very noticeable. In my opinion, I like to do that. And then set it to a transparency that's either half or maybe 60% transparent, so that you can kind of see through it, but any surfaces that poke below it, they will be clearly visible. So yeah, that's basically how to create floor slabs with a slope, and also for multiple slopes, and create a parquet clearance that will reflect the same contours of that slab.